In order to figure out where a function's concave up, we need to find the second derivative. Let's go ahead and do that. The first derivative here will be 4x cubed minus 17x squared minus 6x minus 2. The next derivative will be second derivative equals 12x squared minus 34x minus 6. Now we're going to set this equal to 0 and solve. What I first want to do before I try and factor this is notice I can pull a 2 out of that. So I'm going to say this equals 2 times 6x squared minus 17x minus 3. And this expression will factor into 6x and x. I can put a minus 3 here and a plus 1 here, and that should check out. 6x times x is 6x squared. 6x times negative 3 is negative 18x, but then we have plus 1x gives me negative 17x. And lastly, 1 times negative 3 is negative 3. Okay, what values of x cause this to equal 0? That would be x equals negative 1/6 and x equals 3. Now that I have these two values of x, those are my points of inflection. Those cause the second derivative to equal 0. I'm going to draw a number line and put down negative 1/6 and x equals 3. You're going to pick your favorite number larger than 3 and plug it back into your second derivative. I'm going to say 4 is a good number to pick. When I plug in 4 here, I get 6 times 4 plus 1 is positive. 4 minus 3 is positive, times a positive 2 is all positive, so I get a positive result. Then I pick my favorite number between negative 1/6 and positive 3. A good number to pick between any negative and positive is 0. And when I plug in 0 here, I get 2 times 1 is positive, times negative 3 is negative, so I get a negative here. And then picking my favorite number less than negative 1/6, like negative 1, when I plug that in, I get a negative here and a negative here. Negative times a negative is a positive. Okay, this is my second derivative number line, and this will tell me where my graph is concave up and concave down. The graph of f is concave up when the second derivative is positive, so the intervals we're looking at are negative infinity to negative 1/6, and the interval from 3 to infinity.